Welcome to Brain Vision.
Question number 69 is an emission line question for the hydrogen atom. The Rydberg equation was an equation that was introduced by Rydberg in order to calculate the energies, or more specifically, the wavelengths associated with the energy difference between two quantized energy states in the hydrogen atom. The equation is 1 over the wavelength, expressed in meters, is equal to the Rydberg constant multiplied by 1 over the lower energy state, principal quantum number, over 1 over the higher energy state, principal quantum number. So if we want to calculate the wavelength associated with the transition from a higher energy quantum number, energy level 2, down to 1, this is how we would set up the equation. This allows us to directly calculate the reciprocal of the wavelength in meters. If we take the reciprocal of this number, we will then get the wavelength in meters, and we can convert it to nanometers by multiplying by 1 times 10 to the 9. So the wavelength of emission from a hydrogen atom for an electron going from energy level 2 down to energy level 1 is 122 nanometers, which is ultraviolet light. If we do the same calculation, but for an electron going from energy level 3 down to energy level 1, we would get our 1 over lambda equal to 9.75 times 10 to the 6 1 over meters. The reciprocal of that is 1.03 10 to the negative 7 meters. And if we multiply that by 1 times 10 to the 9, we'll get nanometers of 103. This also is in the UV range. For the next one, we're calculating the wavelength of emission from energy level 4 down to energy level 2. And 1 over lambda is 2.06 times 10 to the 6 1 over meters. The reciprocal of that is 4.86 times 10 to the negative 7 meters. Multiply that by 1 times 10 to the 9, and we get 486 nanometers. So this would be a visible light photon. And for the last one, we have an electron that's going to transition from energy level 5 down to energy level 2. And in the process, it'll emit a photon that has a wavelength of 4.34 times 10 to the negative 7 meters, or 434 nanometers. This also is in the visible region of the electromagnetic spectrum.